Here we go with the first episode of Arduino Made Easy by Tom's Trains and Things. So let's see what we have going on today. I'm Tom Kovichak, and this is Tom's Trains and Things. You know that Arduino can be a little bit intimidating for some people, especially if you don't know programming and electronics, and I'm going to try to make an easy setup of Arduino even easier. So let's see what we got going on today. When we're finished with today's project, it's going to look like this. We're going to flash alternate LEDs back and forth at a given speed. All the commands we use today in this example we could find on the language reference on the Arduino web page. Now, this is a good place to start for anything. You're going to find every command that is built into Arduino in here. And we're going to be using digital write. We're going to be using pin mode, and we're going to be using delay. Those are the three built-in commands that we're going to use, and we'll show you how to use it. This is a good place to start off where you could see how to use those commands. The syntax of it: digital write, pin, and then the value. And then it shows you the parameters for that pin, the pin number, or the value, either high or low. And then it gives you an example of it. So everything that we talk about in here, you could go back and reference it on the Arduino webpage in the language reference. We're going to start with a new sketch, and we're going to actually type in all the commands that are on there. That makes it a little bit easier to understand what you're doing, and you'll be able to retain what you're doing by actually typing it in instead of copying and pasting sections of a sketch. Now, I'm not saying you can't do that. Whenever you have multiple lines that you need to create over, it's all right to go ahead and copy and paste them in there. But for learning purposes, we're going to start out by taking that example sketch and starting a new sketch and writing it from scratch. With the experience of actually doing it, you retain more of what you are doing by doing it that way. We're also going to use a breadboard, some jumper wires, two 330 ohm resistors, two LEDs. Now, they don't have to be red. The example that I'm going to show you here in a few minutes has all clear ones on it, and it's something that I did last night to see what I could do with the basic blink sketch and modify it. Now, let me bring this one up on the screen that I worked at, and I don't want you to get all confused with it because it has a lot of things in there, and I just played around with some ideas. But you can see right here, all of this right here, and pretty soon you'll be able to do this same thing right here. And that's what we're going to work on. We're going to do it step by step. I'm going to show you a little bit at a time. This is the last time you're going to see this sketch right here. But let me show you what that sketch did. This is just to show you the things that you'll be able to do just by modifying that blink sketch that we're going to talk about today. Here we go. See, I sequenced through all 5 of the LEDs one at a time at different rates. And then I do a sweep, like an airport sweep and like a marquee. And then I end up with, and you'll see right here, a crossing signal. if you could do an LED, if you could light up an LED on and off, you could operate relays, you could operate servo motors, you could do anything you want in Arduino with that, starting from the basic blink sketch. Here's the fritzing diagram of what we're going to be working on today. We have our 2 LEDs, we got our 2 resistors, and we got our 3 jumper wires on there. And what I did was I put a jumper across the negative on, so we could have continuity going through on both sides, because we're going to put the LED on the negative over here on this side. Let me get that. Okay, right there. And you can see up on the ground on the Arduino, it connects there, and there's also 2 grounds up on this side up here. Let me highlight this and it'll pop them out of there. See that? And so, and it just went and put a wire right there. So I'm trying to highlight this, and it, there we go. So the cathode goes there. The anode goes right here across. Okay, and what you want to do is when you want to put the resistor on the same line, on the same row as the anode, on both of them. So you put the cathode on your negative rail, and then you bring your anode over here. Now it doesn't matter. I have to show it like a couple of rows over because of the way this is set up, but you could do it straight across. All you need to do is make sure that you have your resistor on the same row as your anode, and it'll work. And then you put your jumper from this line right here, you can see how that is, and put it on the orange one on number 4, yellow one on number 5, and then your ground wire, your negative bus, over on the ground right over there, and you should be good to go. Now what I wanted to show you on the LED here is how this thing is set up. You can see the longer one, it shows that it's bent, and so this one, the cathode, that one goes into the negative, and the anode is the one that comes up here going to your resistor. And I have the Arduino Uno upside down on here, so we can have all the wires going in on the same side, so we don't have to jump all the way across onto the other side. Just looks a little bit neater that way right there. We're going to do something similar to what the blink sketch does, but we're going to rewrite it, and we're going to type everything in and not try to copy and paste anything. When we actually go through the typing of it, we'll learn a little bit more about what we're doing. So I brought up a new sketch here, and let me expand this a little bit. There we go. All right, and you can see the void setup up there. We're going to do things a little bit different than what it had on the blink sketch. Now, as you can see on the blink sketch right here, it started off with just the comments above the void setup, and then it put pin mode under the void setup. We're going to do something different. We're going to declare our components on here, the 2 LEDs and the time that we want to delay the on and off. And the reason why we want to do that, they're called variables, and like everybody else says, it's a bucket, and you put something in the bucket, but you could easily pull that out and change it in that bucket. So you don't have to, if you're using that same thing like the pin, we're going to use pin 4 and 5 for these 2 LEDs right here. Instead of having to go back and change pin 4, say you want to move the pin over to pin 3 instead of 4, and you want to use pin 4 for something else, you don't have to go down through the body of the program to change every instance where you're mentioned pin 4. You go up in the variable that you write for that, and you change it one time and it changes it through the whole program. That's why we're going to use variables up there. So we have to declare the variable. We're going to call it myLED1, myLED2. So the way we do that is with an integer, and that's an int. The integer is a whole number, 0 through 9. There's no fractions, no decimal points, and you could go 1 through 10, 11, 12, 13, 14, 15, just as long as it's a whole number on there. We're going to call it myLED1. You could call it anything you want to. You could call it baloney if you want to. Baloney 1, baloney 2. It doesn't matter, just as long as you know what that is, and we'll show you how we do that. Now we're going to say, okay, myLED1, and we're going to put an equal sign, and we're going to put 4, and then a semicolon. At the end of every instruction, you put a semicolon in there. That's saying that instruction is finished. And you'll see why, because I'll compile something later on without this semicolon in there, and it'll show you it won't accept it. We declared that myLED1 is number 4. We'll put a comment in there. Okay, so just a little comment to let us know what that is. And it's a good idea to put comments in there, because if you go back to this sketch 2 years later and want to see what's going on with it, you're leaving yourself notes for future you, so you can understand, or for somebody else to understand what you're doing in this sketch. So we have in there myLED is equal to 4. Okay, we'll do another integer, and myLED2. So that's going to be the second one. That's going to be this one right here. And we'll equal that as 5. And then put a semicolon in there. And what I'll do here is I'll tab over a couple of times, and we'll just copy that so we don't have to keep writing the same thing. Declare that, and I spelt that wrong, but this is second, second LED. I put an extra deal in there. Okay, now LED1, LED2, we have it right up there. LED1, LED2. Now, the next thing we're going to do, we're going to turn it on and we're going to turn it off for a specified time. So instead of going down into the bulk of the program, we're going to put a variable in there for the on time and the off time. So if we want to change something, we could change it up in the top of the program, so we don't have to go looking for it down in the program. So we'll go down to the next line, and that's also going to be an integer, and we'll go on time 1 equal, and we'll do 1000 right now. We'll come over here, declare on time as 1 second, and go down to the next line. And you can see over here that I forgot to put in the semicolon, so we'll put that semicolon in there. Let me get this thing up on the full screen here anyway. It'll be easier to see like that. Then you don't have to look at my face all the time. Woohoo! Okay, line number 4, another integer, int, off time equal, and we'll do 1500. And that's a second and a half. Now, let me come up here to compile, and I'll show you what happens when you don't have the semicolon in there. And you'll see down here that this turns red, and you'll have tell you why it isn't that way. First of all, I'm going to go right here and hit this check mark. And it's going to want to name it. Let's name it BLINKEXAMPLE, and we'll make it blink example. Now, okay, you'll see right here that it highlighted that line right there. And why did it highlight that line? Let me pull this up. And you can see down here, it expected a comma or semicolon before void. So what we'll do there, we'll put this semicolon in there and do that over again. Bring this down to the bottom, and then you can see sketch was 444 bytes, 1% of program storage space. So Arduino Genuino Uno on COM5, it tells you where it's at. Done compiling. So you know right now that there are no mistakes in there so far. When I left out that semicolon, it told me that there was a mistake in there. When you're getting into writing a lot of lines on there, you could go through it and compile it to see if you made any mistakes, and it'll tell you if you made any mistakes, and it'll tell you where you made the mistakes. Now that we declared, we got on time and off time, and let me write a note in here. Since these came out a little bit further, I'll move these top ones up so it looks a little bit better. And we have a nice straight line for the comments, and you could see we're going to tell the program where my LED 1 is. We gave it a number as 4 and 5, my LED 1 4 and my LED 2 5, but the program doesn't know what to do with that. So what we'll do is, it is a pin, and so we'll write in pin mode, and you can see it turned orange, and we'll give it a parentheses. Inside the parentheses, and we'll put another one on there. I'll give it a little space and put another parentheses in there. Now inside there, we'll put my LED 1, my LED 1, and a comma, and is an output. So now we have my LED 1 is 4, and down here we have pin mode saying 4 is an output. Okay, now you can see why we have a variable there. So we don't have to write 4 in here. We'll use the LED 1 name of the variable, and we have it in there as pin mode. So anytime it sees my LED 1, it knows that that is pin number 4, and that's an output. And then we have to put a semicolon there, a comment, assign pin 4 as output. And we'll come down to the next line. Oops. Pin mode. My LED 2 is also an output. So now we've made my LED 1 output on pin 4, and my LED 2 is an output on pin 5. And we've done all of that with variables. Now in this right here, they practically did it the same way, pin mode, and this is a built-in variable in the IDE, LED built-in. So that's basically the same thing as saying I'm using pin 13 as an output. Now the built-in LED on the Arduino Uno is pin 13. So that's basically saying the same thing right here. Pin mode LED 1 output, pin mode LED 2 output, pin 4, pin 5 is an output. And we'll just go over here. We'll copy that. Move this down here. And change this to 5. And we're all set right there. Now, it's time to get into the loop. Now here's where we get into the meat and potatoes of what we're going to do. Now, if you remember in the blink sketch, in the loop, we have a command here that says digital write, and we have a delay, and then we have digital write again, and then we have another delay. And what we're telling it is we want to write to that pin, and we want to give it an instruction of high, and then we want to delay that. We want to keep it high for a certain amount of time. Okay, and then after that, we want to give it another command. So we're going to write digital write again. We're going to identify what pin and what we want to do with it. Low. We want to turn it off. So how long do we want to turn it off? We want to turn it off with a delay for 1 second. And so it's going to loop on and off, on and off, on and off, on and off through those instructions. Now we're going to do it a little bit different than how they did it there. So how are we going to do it? We're going to give it the same instructions, but we're going to use those variables. We're going to start off with digital write. Now you'll see I started off with a small letter on the first word and a capital letter on the second word. And that's how most of the instructions go. Now digital write. So we're doing digital write, and we'll put a parentheses in there. Now, what do we want to do? We want to turn on pin number 4. So what do we have pin number 4 as addressed as? My LED 1. So we'll put in my LED 1. And what do we want to do with it? We want to turn it on. So we'll put high. And what we're saying right there, digital write, my LED 1, high, we're going to turn it on. So let's compile that and see what happens. Okay. There's no error message on there. So everything's hunky-dory right now. We're going to upload it to here, and we'll see what happens. And it turned it on, because that's what's in the loop. It says high. So let's turn this to low, and then upload it again, and it turned it off. But we can't be going there and changing the program over and over again just to get it on and off. So what we're going to do, we'll do the comments in a little bit here, and let me bring the full screen up. Now that we have the digital write, we'll turn this one back to high. And you'll notice that this instruction high is in all capital letters. This instruction out here, output, is in all capital letters. Now we're going to go over, and we want to keep it at high for the on time. So we're going to say delay. We're going to delay for how long? On time 1. And I just noticed something up here that the off time I didn't put 1, so we could put 1 up there also for off time. And we'll close the parentheses and put the semicolon in there. So now we turned it on for 1 second. So let's compile this. Let me bring it back to here where you can see everything. Let's compile that. Now, the reason it stays on, even though we have this set for 1 second, the reason it stays on is it's going through that loop. And it's going over and over and over and over and over again. So you never see it turned off. So what we have to do here digital write my LED 1, comma, LOW, and a semicolon, and we'll put a delay in there again, DELAY, and say off time 1. Now see, if I would have put the 1 here and then left that one up there without the 1, I would get an error in there. So we got off time 1. Here's that and the semicolon, and we'll upload this. And you can see it's on for a second and off for a second. Now, since we got a little bit more time, we're going to do pin number 5, but we're going to do that just the opposite. Okay, so what we're going to do here, we're going to do DIGITALWRITE, and then we'll do pin number 5, which is my LED 2, my LED 2, and LOW. Now you see what I'm doing here is when pin number 4 is on, pin number 5 is off. Two HIGH, that, and delay 1. Okay, now we gave it an instruction on here. We want the first LED, number 4, to be on, and when that one is on, we want number 5 to be off, and we want that to do it for 1 second. And then after that, we want to do just the opposite. We want to turn off this one and turn on this one for 1 second. Now let's upload that and see what happens. and we got an error in there. So I must have missed something. Oops, I put a right there. See, it identified it right there on the bottom. I put a period in there instead of a comma. I hit the wrong key, so it tells me that I hit the wrong key. So this is a good tool right here. If you make a mistake, it's going to tell you you made a mistake on there, and it's going to show you where. You just have to go up in here and find it. Okay, now let's do that again. Okay, now you see we got them flashing back and forth. Okay, so what if we want to make it faster? So we got on time as 1 second and off time as 1.5 seconds. So what if we wanted to change this? We could change it right here. We'll make it 500, which is 1/2 second. Oops, I could just delete the one right there. 500, and upload that again, and we'll see that it goes a little bit faster. Okay, that's a little bit faster. So let's go down to maybe 300 milliseconds. You could use that on your railroad crossing now. It's as easy as that. Just those little bit of lines of code, and it'll get you to flash your lights back and forth just like that. That's where we're going to stop today. We got that going in a matter of minutes, and all we had to do was set up the board, how we were going to do it, and then write the code for it. Now, when I first said I was going to do it, I said I was only going to do it for one, but since, you know, it only took 2 more lines of code to get the other one to work, we just did it. It took, what, 20 seconds to write 2 other lines of code in between the first LED, to put the second LED in there, to get them flashing back and forth. We changed the variable on the time, on time and off time, to get it to flash faster, to where we was satisfied with the speed of the flash. Now you could change it to anything that you want, but 300 milliseconds looks pretty good for it flashing right there. So that's where we're stopping today. Next lesson, we'll go a little bit further onto it, and we may add a few more LEDs so we can do a little bit more on there, and we'll work on some for statements and while statements so we can get things happening over and over again under a condition. So that's it for today. We'll see you.